Right, I just want us to go through the whole process of neighbor discovery together, going through Manos Edu and see if Tinosika point if we agree on something. All right, let's start here. Neighbor solicitation, neighbor advertisements are used for device-to-device messaging, such as address resolution. Device includes both host computers and routers. Okay, this is the device messaging, device router messaging. Okay, let's skip. I want to look at the working principle. Much like ARP, IPv6 devices use neighbor discovery to determine the MAC address of a device that has a known IPv6 address. So neighbor solicitation and neighbor advertisement messages are used for MAC address resolution, similar to ARP requests and replies used for IPv4. For example, PC1 to ping PC2 to determine the MAC address for the known IPv6 address. PC1 sends a neighbor solicitation is illustrated. Right? Neighbor solicitation says, whoever has this address, send me your MAC. So this one is for a local network. I think it's very easy. For a local network, no problem. Let's find the one in a remote network. And I think this is the lab Rangarutarona Sharon. Okay. For the remote networks, haipo pana. Okay. Ndopangauritaura panapa Sharon in order for a device to communicate with another device. Let's Google it. Am I audible? Am I audible?
Yes, or maybe you can just simply go to your net card, net card account. Tungenda ma video yacho maybe.
All right, let me find the video. Let me log in. It's getting a bit interesting. I was trying to do this instead. Because once I log in, it might take me some time. Let me do this instead. Let me share my screen. Right, let me share this. And Shimchadu. Yes, yes. Okay. So let's ask about IPv6 neighbor ND for remote communication. Let's see if we can get a summary of that. Because for local networks, I think it's very much straightforward. It's more like ARP for local networks. But for remote communication, how does it happen? Relies on protocols? No. Neighbor discovery is not designed for remote communication. It's also local as well. Yeah. Let's go to the video. Let's go to the video. Let's see. Let's be patient with this one. All right. Meanwhile, network I'm going to see what's there. Okay, I was already logged in. And the 9.3, it's 9.3, 9.3. There is no video. It's a lab. I see video. It's a lab, right?
Ayo, iri pam 9.3.1.
All right, 9.3.1, this one. All right. We cancel this. Let's look at this one.
In this video, we will discuss the process of how IPv6 performs address resolution using ICMP v6 neighbor solicitation and neighbor advertisement messages. This is similar to the ARP process used by IPv4, but has certain advantages that we will see in a moment. Host A has a packet to send to host C. Host A has determined that the destination IPv6 address is on the same network as host A. Host A knows the destination IPv6 address, but needs the associated destination MAC address, so it can encapsulate the IPv6 packet in an Ethernet frame to send directly to host C. Host A.
All right. Let's digest this report so far. We are trying to send information from A to C, right? From A to C. Yes. So far I can see it's a LAN. I also see a LAN as well. If we're trying to send from A to C, we can just broadcast a request. This is me thinking. We can just broadcast a request from A and C responds with its MAC address. Let's continue. Let's see.
Examines its neighbor cache to see if there's an entry for this destination IPv6 address. Similar to an ARP table, the neighbor cache maps IPv6 addresses to MAC addresses. For simplicity's sake,
You haven't complicated anything. The reason why the end quest over is because
MAC
everyone wants
addresses
to
are shown
learn, including myself.
as 4
Don't
text
worry.
symbols instead of the usual 12. As we can see, there is no MAC entry associated with this IPv6 address. The IPv6 packet is placed on hold, and host A creates an ICMPv6 neighbor solicitation message. This is similar to an ARP request used for IPv4 address resolution. One significant difference is that
All right. Let's end it here. Ndawana Sangaro Tauro. Do you see this multicast here? Can see destination IPv6. I don't know when I can say Angry Wanega. Do you see this against destination IPv6 SN multicast? Yes. Right. That's one happening actually. Yes. When we talk of my IPv6 addresses, we don't have a broadcast. Kana tiri ku-ARP patinosenda a request tinoisa a broadcast, correct? I need someone unmute tinyatsofambe tese. Kana tiri ku-ARP,
Yes, sir.
exactly. When we send a request tiri ku-version 4 IPv4, we send a broadcast to the network. Then in a IP address yatasenda yovera respond. Kana taku IPv6, we don't have my broadcast ku IPv6. That's why this multicast is being sent. Do you get it? I'm ndo pane nyaya and I feel like ndo pane nyaya. That's why pane multicast here. Ndo pariri kubudira ipapo.
Right. So say the multicast series ndo rinenge rine like maybe the longest inoshandisa the longest prefix iri closer to the ndizvo pa IP address yacho.
Inoshandisa chi?
Like handi painosenda multicast apa handitika inotarisa like ma IP addresses handitika. Say apa handine destination IP iri kuda destination mark handitika. Saka inozosenda iri multicast in the sense yekuti inenge yatarisa like yaexamina like the IP address yacho handitika. Then inosenda multicast kune those are closer to that ari kumeasure that ari kuda the closest pakumeasure that inenge iri IP address iyoyo.
Okay. Let me respond in this way. Let's go back to what and look at what ARP and neighbor discovery is. Let's go back. Ndukusvika kune answer yako. Just a minute. I want to share this screen. Just a minute. Right, PDF ndo hapa. All right. And we're going to PDF. My screen is PDF, right?
Yes.
Right. Let's start with ARP. Let's understand how an ARP request is sent. So in a network, let's talk of a network LAN. To the PC 1, 2, 3, 4. We know the IP address of this PC. We want to send from 1 to 4. We know the IP address of this PC, number 4. So, 1 is a destination mark. What does it do? It sends an ARP request. An ARP request sendwa where information yekuti inini ndine IP address yandinayo, which is IP address number 4. I want to know the destination mark. So packet information iri rino broadcast. It needs to be broadcasted. That's what an ARP request. So broadcast is roti packet information richawe apa. Then panapa it gets dropped because the destination iripo iruchagwa in number 4 you. It gets dropped panapa. Then this one responds near destination mark. So that's how an ARP request near response yacho works. Right. Tikazoenda ku IPv6 now. Tikazoenda ku IPv6, the difference ndeyekuti, okay, the similarity, let's start there. Ndeyekuti a message needs to be sent to all the devices first. But ku IPv4, we can send what we call a broadcast. However, ku IPv6, hakuna chinhu chinonzi broadcast. Kune inonzi multicast. So multicast yeku IPv6 yakada kufanana ne-broadcast. Kana ukasenda to all the devices, inenge yakada kufanana ne-broadcast yeku IPv4. So it's the same thing. Multicast iyo yasendwa panapa rinodropwa, and this one responds with the correct IPv6 address. So I think patengera confusion yedu ndo ipapa pekuti request rasendwa rakanzi multicast. Multicast iyo musoro menyu itorese broadcasting. Because ku IPv6 hakuna chinhu chinonzi broadcast, kune inonzi multicast. Question yazobvunzwa naLloyd inogona complicatera zvinhu. Rega ndimbogumire apa nditi, did you understand the process yeARP request neresponse yacho? Did you get that one?
Yeah, I understood, see. But my question still comes back, Pakuti. And you see,
Yes.
Panos, they said the ARP reply, Handiti, the process ARP reply. So I don't want to understand it in the IPv6 context now. Talk with the reply, Yach. Because that's where my confusion still is.
Okay. Apa patasvika apa regaticokera kuvideo toona kuti response yakaita sei. Let's continue.
That ARP messages are sent directly over Ethernet. IPv4 is not involved. The IPv6 address resolution process uses ICMPv6, which is then encapsulated in an IPv6 header and then encapsulated in an Ethernet header and trailer. The ICMPv6 neighbor solicitation header includes the target IPv6 address, which is the same destination IPv6 address in the packet that is on hold. The target IPv6 address is mapped to a special IPv6 solicited node multicast address, which is then mapped to a special Ethernet multicast MAC address. This mapping process contains a significant portion of the target IPv6 address. This allows for the Ethernet NICs on each device that receives this frame to determine whether or not to accept and process the frame. This is where we see an advantage of ICMPv6 neighbor discovery over ARP for IPv4. Since ARP uses an Ethernet broadcast address, all devices on the local network must at least partially process an ARP request. The ICMPv6 neighbor solicitation message is forwarded by host A and received by the switch. The switch will flood the Ethernet multicast frame out all ports except the incoming port. Host B receives the Ethernet frame. Host B's Ethernet NIC examines the destination MAC address. The Ethernet NIC will accept frames whose destination MAC address matches the MAC address on the NIC, is a broadcast MAC address, or a multicast MAC address that maps to one of its IPv6 addresses. In this case, the multicast MAC address does not match any of these, so host B's NIC ignores the rest of the frame without having to pass it up to an upper-level process to make this determination. Again, this is an advantage over ARP for IPv4. Router R1 receives the frame on its LAN interface. A similar process occurs on R1's interface. The Ethernet NIC ignores the frame because the destination multicast MAC address does not map to any of its IPv6 addresses. ICMPv6 neighbor solicitation messages are not forwarded by the router. This is because the solicited node multicast address in the IPv6 header is sent with link local scope, which tells the router not to forward these packets off the local linker network. Host C receives the Ethernet frame. This time, the Ethernet multicast MAC address matches a MAC address associated with host C, specifically the one mapped to host C's IPv6 solicited node multicast address. Therefore, host C accepts the frame and passes it up to its IPv6 process and then its ICMPv6 process. The target IPv6 address in the ICMPv6 header matches its own IPv6 global unicast address, so host C knows it is the target of this neighbor solicitation message. Before replying, host C adds the IPv6 and MAC address of host A to its own neighbor cache, so it can return a neighbor advertisement message. Host C replies with an ICMPv6 neighbor advertisement message sent as an Ethernet unicast message directly to host A. The ICMPv6 header includes host C's IPv6 address, which host A already knew, and the associated MAC address that host A was requesting. Host A receives the Ethernet frame, examines the IPv6 address and the MAC address in the ICMPv6 header, and adds it to its neighbor cache. Host A can now take the IPv6 packet off hold. Host A updates the destination MAC address with the address associated with the destination IPv6 address and forwards the frame and IPv6 packet to host C. Note that if the destination IPv6 address was on a different network, this same process would occur to discover the MAC address of the default gateway, which would map to R1's IPv6 link local address on this LAN.
Right. Bunzana mpindurane John. Bunza futhi Sharon, what was the question? And I want Lloyd to answer that question. And also try again. What was the question again?
Question yangu engaekuthi the ARP continue to the request process. Just it at the ARP reply process yacho when you are now getting the MAC address, the destination MAC address. So I wanted now for it to be related for IPv6 since pane that SN multicast address. But now the reply actually say.
I just realized you're not watching this video. Why did you not say video as warning? Hey, Heba. Heba. Right. Let me try again. I think it's very interesting. Good morning video.
Pass it up to an upper level process to make this determination. Again, this is an advantage over ARP for IPv4.
Can I write on the screen? Unfortunately, I cannot write on the screen.
Router R1.
Let me be a bit creative. Destination MAC, destination target. Right. I think I can work with this. Just a minute. Just a minute. Let's do this. Right. Screen langu riri kuoneka ke? Right, let me choose red. Riri kuoneka ne? Right. So, kana tidhila ne-ARP, kana tidhila ne-ARP, request tati tikaisa network. Let's say I'm trying to communicate with, let's have the same thing. I think it makes sense. Pana 1, 2, 3. Pana 1, 2, 3 my devices. This is A, B, C. Then this one leads to the route. Right. So I'm trying to send information from PCA to C. Right. Pandinesa ARP request. Kana tiri ku-ARP tiri ku-version 4. Let's look at this part. Iri an Ethernet header. Panapa, let's replace toisa IPv4 header. Tono kuti ringa rakaita sei. Kana tiri ku-ARP. Kana tiri ku-ARP, since request ichasendwa sebroadcast, zviri kureva izvo kuti panapa padestination IPv4 inenge iri broadcast yemunetwork. Panapa palayer 2 inenge iri broadcast ina FFFF. That's the broadcast mark. I think pese pataita ARP iyi ndo yabuda iyi. Kana tiri ku-ARP ndo inenge iri broadcast inenge iri address inenge iri panapa. Iyi source iyi haichinje. Source IPv4 haichinje. Then the target IPv4 ndo IPv4 yepanapa. Let's put a question mark panapa pa destination multicasting. But I'm thinking panenge pane broadcast IP address. We can do that. Ndo ku-ARP. ARP process ne-neighbor discovery dzakafanana basically. Chakangosiyana ama-terms ari kushandiswa. So now instead of having FFF up, broadcast mark, tane destination mark multicast. Multicast because ku IPv6 panapa hatisina chinonzi broadcast, tane inonzi multicast. And the multicast iyoyo, take it as broadcast for now. I think take it as broadcast in your heads. Take it as broadcast. Why? Because every device in the network will probably belong to that multicast. Right? So panapa, instead of having broadcast, tane multicast. Panapa, instead of having broadcast, tane multicast. But each it remains the same. This one remains the same. This one remains the same. And kana yaku responder. Now, if this one wants to respond, you have to send a unicast in where direct to PCA. So ARP request, if I can do this, let's summarize this. Let's summarize this once and for all. That is bad data. Todzokera tombonoverenga a little bit. So if we are talking ARP, if we are talking neighbor discovery, the huge difference iri pakuti kuno kuti nebroadcast patinosenda request kuno kune multicast. Multicast yacho, every device in the network will most likely belong to that multicast. Right? Panosendwa response, I think panapa unicast. That's one video futhi with unicast pana. What's happening? Right, unicast as well. So the huge difference iri pa understand these terms only up. Are we getting any close, Sharon? Kuti zvinhu zvakafanana izvi. Chakasiyana ma-terms. Yes, clear. Well, but I like this. I like this. Chakasiyana ama-terms and the way my response, uh, how do I explain this? Okay, I think for now, let me just stop here. Next time, I'll look at this and find a better way to present this ARP neighbor discovery. I also want to urge you to mutariseo in your own way. I think we've discussed this at length. Try to go back and try to look at this at your own way. Kana uchikwanisa ku paraphrase, rephrase whatever the question you wanted to put across, your foot in another way. But I think for now, ngatimire kuti ARP request rinosendwa riri broadcast, neighbor discovery rinosendwa riri multicast. And the reason ndeyekuti hakuna broadcast ku IPv6. Right. Sure. Let's go back to also rewatch this video. I think this video explains almost the same thing as how I've been explaining. Almost the same. This video. Go and watch it. Right. Let's go back to my questions here, okay? Ndichanyatsogara pasi ndotry kutsvaga the best way to explain this because I might be missing a thing or two as well. It's possible. It's possible. All right, let's go back to PDF Redo. All right, number 3. Wait, number answers. Number. Okay, 10. This is the module. Number 20. And number 20, that local. Number 21, under which circumstances will a switch flood a frame out of every port? Under which circumstances will a switch flood a frame? The frame has the broadcast address. Yes, it will get flooded. The destination address is unknown. Yes, it will get flooded. The source address is the broadcast address. Source address haiti kuti broadcast address. It's impossible. Source address in the frame is a multicast address. Can a source be a multicast? Maybe, but it's definitely not the answer because Tine 2 are definite. The destination address in the frame is known. If it's known, then unicast no sendwa. So the circumstances that no flood a frame out every port is when the destination, the frame has the broadcast address as the destination, right? Is when the destination is F. If the destination is FF, this is the destination you're broadcasting. It's sent to every port except the incoming port. If the destination is unknown, can I still zero to the destination MAC address we broadcast as well? Then what happens after? I just got a brain freeze. What happens if we have an unknown destination address? The destination address is unknown to the switch. ARP. Into ARP. We send a broadcast as well. I think I just had a brain freeze somewhere there. So it is. It should.
Yes, sir.
Cannot marasika go multicast.
Multicast akapachika zvese zviri kufamba.
Right, let's go. 22. Which statement describes the treatment of ARP requests on the local link? On the local link, they must be forwarded by all routers on the local network. pangotanga tala router chat inini ndombotanga kubvisa. Let's eliminate some answers. Yenyu ndeipapo. Possible answer yenyu. Possible answer. Someone in the chat. B. They are received and processed by every device on the local network. Which statement describes the treatment of ARP requests? Yes. I think this one makes sense. B. Right. They are dropped by all switches on the local network. They are received and processed only by the target. No. Right. B for that one. Which destination address is used in ARP request frame? Request frame destination C. Right? I think ukwafa floor because go C broadcast. Right? A network technician issues an ARPD command on a PC after the router is connected to the LAN. What is the result of this command? Deletes A. Clear the cache, correct. That's ARPD. Alright, number 25, refer to the exhibit. Is there an exhibit there? What will be the switch? Upon exhibit, number 25. The exhibit shows a small switch network and the contents of the MAC address. All right, let's skip number 25, exhibit diaper. Number 26, which two types of IPv6 messages are used in place of ARP? Tabanengo. I just get up on the neighbor solicitation, neighbor advertisement from B. What is the aim of an ARP spoofing attack? Spoofing attack is to pretend like you have the correct C. To associate IP address to the wrong MAC. To flood, no. To fuel, no. To associate, to overwhelm, I think definitely C. Right, buffer no farm bigger. Refer to the exhibit. Right. C. Refer to the exhibit. PC1 is trying to connect to file server 1 and sends an ARP request to obtain the destination MAC. So we're trying to communicate from PC1. Let me do this. PC1 to the server. Which MAC address will PC1 receive in the ARP reply? It will get that one of the default gateway. Because ARP, I put it outside the network, basically. So answer it up should be router 1. Answer is F. Router 1 G00. Right. My power is getting a bit low. Let me pause. All right, so for this one, we are saying PC1 wants to communicate with the server. So this wants to communicate with this. Pano send by a request from PC1. Inogumira pana. So our answer is F. Ndosangati mbotaura sekuti ARP haibude munetwork. Inogumira pa default gateway. Then painouya panapa. Ino request our app. You respond app. Then painosvika app. Inosend app. You respond app. Then frame rate will also send to the destination. Everything is local. Right, that's number 28. Number 29, where are IPv4 address to layer 2 Ethernet address mappings maintained on a host computer? So the mapping is not this, it's definitely not this. By elimination, our answer is B, ARP cache. Number 30, What important information is examined in the Ethernet frame header by a layer 2 device in order to forward the data onward? Header in a source and destination mark. So to forward data, we look at the destination mark. Yes. To forward data, you look at the destination mark. Right. Number 31, match the commands to the correct actions. Password class, banner. I think, okay, let's do this. This one matches with this banner. Security for console. Hey, security for console, I think is this one. Line. Then name of router. Apana name of router. Configures a name on the route. I think these two are the only ones I can match. This one, inologashi. What does command number 2 do?
Look at my visual lines.
Nyepa. Nyepa chaiko kunyepa. Kunyepa.
Line console. Oh,
Privilege mode, exactly. The privilege mode. Then this one, password Cisco. Yeah, kuna command. Iriko eh? No, this one I don't know about it. All right, let's continue. Number 32, less than 1 minute. All right, iriko ndepachi hakuna iyo ndokuisira discount password
Yeah, is it Zanga GT enable password there? Enable secret.
Let's continue one more session. I think time area pair up. Let's continue things go down when I discount.
Say iriko kumarute.
Let's continue to know each other. I'm stopping sharing here.